Broadly speaking, simplicity is a good heuristic, and the sort of literature on simplicity biases in deep learning does tend to say, like, this is the explanation for why models generalize, right? If they didn't have any kind of simplicity bias and they just started out incredibly complicated from the beginning, within phenomenology, there is different sort of ways of thinking about what experience really is. I think Edmund Husserl might have been more close to kind of an idealist perspective. He was famous for this idea of the epoche, where basically you're looking at your experience, you're describing it, but you try to refrain from assuming that your experience is reflective of some objective reality. Other phenomenologists like Heidegger or Merleau-Ponty are usually seen as being less idealist, especially Merleau-Ponty, whereas a lot of people, when they think about idealism, they'll say that, like, well, your experience doesn't actually include people, windows, objects, because that's an interpretation of your experience. Your actual experience is just like colors and like raw sounds, like uninterpreted raw feels. And they'll say that's the thing that's real. The interpretation is like kind of fake or something. Merleau-Ponty wants to reject that because he says, like, okay, look, the very idea that you're seeing raw colors separated from the objects that have the colors is this kind of post hoc abstraction that you get from philosophical thinking. But really what's there in your experience is just like objects that have properties like colors and stuff. But like the object is there and you kind of experience it directly.
Do you want to run Llama efficiently on smaller GPUs? What if you could run both training and inference on the same GPU? With CentML's breakthrough optimization technology, you can maximize hardware utilization and slash AI computation costs. Running LLMs at scale shouldn't break the bank. CentML's intelligent optimization platform helps enterprises deploy AI models with maximum performance at minimum cost. Experience the difference. Nora, welcome to MLST. It's amazing to have you here.
Yeah, I'm glad to be here.
Yeah, it's amazing to meet you. Can you tell us about yourself?
Yeah, so I'm Nora. I'm the head of the Interpretability Research team at EleutherAI. We're a nonprofit AI research organization that got started just a couple of years ago. We started out as a Discord server. We still do a lot of our research kind of out in the open on Discord. And yeah, so that's what I do in my day job. And I'm here at ICML to present my most recent paper.
What are your main research interests?
So there's like a few different topics that me and my team, I collaborate with a few other people at Eleuther, are interested in. I guess one of our research interests is concept erasure and concept editing. Concept erasure is kind of a set of tools that can be used for a few different purposes in deep learning. So one application of concept erasure is fairness and bias reduction. We all know that models like language models often pick up on kind of the biases, kind of harmful biases about protected minorities in their training data. And we often want to try to mitigate those biases. There's a question of how to do that. With concept erasure, what you're trying to do is you're trying to look at the internal representations of the network and remove information about the target concept. So it might be race or gender or something, entirely different, like part of speech, but you're trying to get rid of this targeted information in the representation while kind of keeping all the other kind of benign information present in the representation. And there were some, this is kind of a pre-existing literature that goes back like a few years before we got into it. But just last year, we put out a paper called LEACE Squares Concept Erasure that introduces a new way of doing concept erasure that has some nice mathematical guarantees.
So what does it mean to erase a concept?
Exactly. So that is a somewhat tricky question. The way that the literature has kind of chosen to operationalize this idea is to say, okay, look, we're going to measure the amount of information about our target concept by basically training a probe, so it could be a linear classifier, for example, on the representation to try to predict the concept, race, gender, part of speech, whatever it is. And if it turns out that the classifier is unable to, predict the target concept better than chance, it's just, predicting 50-50 on every input or something like that, then you can say, okay, there's no linearly available information about the concept and the representation. There's always a concern that, well, maybe your classifier isn't strong enough. Maybe a more expressive or stronger classifier would be able to extract the information. But you kind of have to start somewhere. And so that's the approach that we take in the LEACE paper as well. We consider the linear concept erasure regime, where you're trying to make sure that no linear classifier can extract information about the target concept.
So what's the backstory here? I mean, how did you start all of this?
Yeah, so I wasn't initially kind of interested in concept erasure kind of for its own sake. Me and my collaborator Alex work on a totally different project where kind of as a subproblem in that project, we wanted to kind of remove information about a particular concept. In that case, it was not actually about fairness. And so, for that project, I did some kind of literature review. I looked into like the existing methods at that time for concept erasure. And one of them was called RLACE. So that stands for Relaxed Linear Adversarial Concept Erasure. And it's, RLACE is a pretty cool approach, actually. Basically, the idea is that you've got this linear classifier, and you also have an orthogonal projection matrix. This is a slight simplification, but this is basically what's happening. So you've got the classifier, you've got the projection matrix, and you're simultaneously optimizing both of them in kind of an adversarial setup, sort of like a GAN scenario, if you're familiar with that. So you're optimizing the classifier to try to predict the concept from the representation, but you're also optimizing the projection matrix to like maximize the classifier's loss. And you're going to take like one step on the classifier, then one step on the projection matrix back and forth. And eventually, hopefully, you'll reach a fixed point. And so it's this kind of adversarial game. And so that does work pretty well. But it does have some problems. In particular, it's like a very slow and kind of tricky to get it to converge. Like sometimes it'll get in circles and stuff like that. And I wanted to basically speed up this concept erasure technique for my own purposes. And so I looked at this other paper called Spectral Attribute Removal. This is a different concept erasure technique where so what they do is they compute the cross-covariance matrix between your representation, which let's call it a vector x. Okay, x is your representation that you're getting from your neural network or whatever it is. And then z is like some other vector that's representing, whatever concept you care about. And we're computing the cross-covariance matrix, so like each entry of that matrix is like a covariance between the like entries of x and the entries of z. Okay, so we have this matrix, and then you're going to do SVD on that matrix to kind of basically to find the kind of directions of maximum correlation between your representation and this concept. And then they just do a projection to like remove those kind of directions of maximum correlation. So it's a very simple technique, and it's fast. SVD is fast to compute. And so what I did was I was like, okay, I'm going to use SAL, this method, as an initialization for RLACE. So I'm gonna do SAL to get the projection matrix, and then I'm gonna run RLACE with that initialization. And it turned out that if you use that initialization, RLACE, like it just immediately converges. Like you don't like basically if you start out with this initialization from Sal, the classifier just cannot do better than chance at predicting the concept. Just immediately. There's no like additional optimization steps that you need to do. And I was like, what? This is crazy. And it wasn't immediately like I was like, okay, I don't know why this is happening, but there must be some like mathematical reason, like some proof that you could give that like actually Sal and RLACE are like the same thing or like something like that. And so I actually tweeted about it. I was like, or I didn't tweet this like exact, I didn't tweet about like a Sal and RLACE, but I tweeted kind of about this mathematical problem. And then one of my Twitter followers, David Schneider Joseph, shout out if you're watching, responded, and he suggested like a proof to kind of connect Sal and RLACE together, basically. And then basically we started talking, and kind of one thing led to another, and we like produced some more proofs. So we realized, okay, there's this close mathematical connection. Actually, there's a mathematical equivalence that you can prove between linear guardedness. So that's the technical term for when a representation. Well, I should back up. When a linear classifier cannot do better than chance at predicting a concept. When that is true, then the representation is linearly guarded for this concept. Okay, so let's consider some concept that has like two possible values. It doesn't matter what the concept is. And you can compute the average representation of basically the average representation where the concept takes the value 0, and then the average representation where the concept takes the value 1. These are kind of the centroids of the two classes. And it turns out that you have linear guardedness if and only if the centroids are equal. So when the mean representations are equal for the two classes, then you have linear guardedness. That's what we were able to prove. And then we went further, and we actually derived the least squares solution for a kind of transformation that guarantees linear guardedness. So basically, we have this closed form formula that you can write down on a t-shirt that kind of transforms the representation so that the means of the classes are equal, and therefore you have linear guardedness, and it is changing the representation as little as possible. We call that surgicality. And that is what LEACE is.
Why is a closed form solution good?
Yeah, so closed form solution just means that you don't have to do kind of gradient descent or like some like compute heavy optimization to try to find the solution. You do have to do SVD as part of it, but that's pretty fast. Yeah, it's just, you can compute it, and you have a proof that it will be the optimal solution.
So there was a great figure in the paper where you were talking from a high level what the process is. Can you talk us through that figure, and we'll show it on the screen?
Yeah, right. So basically the way to think about this is what LEACE is doing is it's first whitening the representation. Now what do we mean by whitening? Okay, so if you imagine the data as kind of a cloud of points, okay, the cloud might start out as like a perfect kind of spherical shape where it's like the kind of same like variance in all directions, but usually your data is not going to look like that. Usually it's going to be kind of like some weird ellipsoid, or maybe there's like multiple clusters all over. You're going to have different amounts of variance in different directions. And what whitening does is it makes sure that in every direction, the x-axis, the y-axis, the z-axis, in any direction you choose, the amount of variance is precisely equal. So that's kind of a first pre-processing step that LEACE is doing. And then once you do that, it does an orthogonal projection to kind of squash the data onto a hyperplane, which ensures that the means are equal. Basically, if you have like two classes, you can imagine like a cloud of points over here and a cloud of points over here. Here's like centroid 1, here's centroid 2. You're looking at the difference between these two centroids, the kind of like line that connects the two centroids. And you're smashing all of the data onto the hyperplane that is normal to this line. So that's what you're doing. And then you undo the whitening at the first step. And that's what LEACE is doing.
So by projecting onto this hyperplane, you're making sure the means are the same. Therefore, you've scrubbed the concept.
Yeah, exactly. And you can like a slightly simpler thing than LEACE is to forget about the whitening and unwhitening step and just directly do the orthogonal projection onto this hyperplane. That also works, and we prove that does give you linear guardedness, but it is not surgical in the sense that you are kind of changing the representation more than you need to. And we think this is important for a couple of reasons. So just in general, if you're changing, like anytime you change the representation of your neural network, you're probably going to reduce its performance to some extent because like it's been optimized by SGD to like do as well as it can on your task. And so you want to be very careful with changing anything. And there's sort of a different reason for wanting surgicality. So one use case for concept erasure that we haven't talked about yet is just interpretability research itself. So in the LEACE paper, we actually do this experiment where we look at how much do language models depend on or use part of speech information to make their next token predictions. And with concept erasure, you can actually kind of operationalize and formalize this question because you can say, okay, we're going to use LEACE to remove the linearly available information about part of speech in all of the layers of the network. So we're going to go into every layer and change and apply LEACE to the intermediate representation. And then we're going to like run the forward pass that way. So we're kind of inserting LEACE into the forward pass at every layer. And for this type of kind of question, you do want surgicality because you want to kind of remove the part of speech information while keeping everything else the same, or at least as similar as possible to like what you started with, right? So you're kind of isolating the affected part of speech. And interestingly, we do find that, of course, when you do this to language models, and we looked at Llama 2 and the Pythia series, it obviously does increase the loss, next token prediction loss, quite a bit, but it actually, like models are still able to predict the next token like way better than chance, or way better than the kind of like baseline entropy of like what's called unigram entropy. It's kind of a baseline for next token prediction. They still do better than unigram entropy when you do this. So it's kind of, they're using the part of speech information, but they're like also robust enough to like rely on other cues when you remove that info.
Can you tell us about the setup of how this thing is trained? So there are these one-hot vectors which represent different concepts. And do you see that as a potential form of brittleness? I mean, how were those concepts labeled and how were they kind of trained into the model?
Yeah, so I think this is one potential problem with applying concept erasure is just that you do need some source of labeled data to kind of define what your concept even is. In the case of part of the part of speech experiment, we used this kind of commonly used NLP library called Spacey. They have their own fine-tuned transformers that can do part of speech labeling. So we just applied that to the Pile data set and got labels that way. But yeah, if there's like if your labels are kind of incorrect, you might not be, LEACE might not do exactly what you think it should be doing, like if your labels are wrong. But I think that's kind of true in general with machine learning, right? You want to make sure that your labels are as accurate as possible.
Yeah, really interesting. The other thing is that this is a post hoc method, which is to say you have a frozen base model and then you can apply it sequentially through the layers. And it can be done quite efficiently, I think you said in your paper. So you could potentially do it in a streaming fashion and do it really quickly. But would you ever consider using it as a method to kind of scrub concepts out of the base model, almost like a fine-tuning type system?
Yeah, so if you want to take a model that's already been trained and then apply LEACE to it, you can actually kind of burn LEACE into the weights in a way that's like very similar to how LoRA does it. So LoRA stands for low rank adaptation. It's a parameter efficient fine-tuning method. And you can do a very similar thing with LEACE, because it turns out that if you look at the kind of LEACE solution, it's actually a low rank perturbation of an identity matrix. And so, yeah, you can just do a little bit of algebra and it turns out you can like just do this like low rank update to the weights and like put LEACE into the model post hoc. There's also another thing that you can do, which we have played around with a little bit, but we don't have like good experimental results on it yet, which is just to apply LEACE kind of in a streaming fashion during training. Like from the beginning of training, you're just like applying LEACE, like, and you're also updating the LEACE eraser. We call it an eraser, the LEACE transformation. After every training step or every few training steps to kind of like keep up with the model's representation as it trains. This is something you can do. But like I said, it's kind of early days for that, and it's unclear if that gives you like a big boost over just doing it post hoc.
What kind of effect does it have on headline benchmark accuracy? Because I suppose what we're doing is we're removing some forms of statistical information from the model. Does it have a dramatic effect, or what have you seen?
Yeah, so it does. It depends a lot on the type of concept that you're erasing, right? So, in the paper, with the part of speech experiment, we were really targeting a concept that we had reason to think like would affect performance, right? And we wanted to see how big that effect was. And that was a substantial effect. I mean, I would forget the numbers exactly, but I think in some cases we were like doubling the perplexity of the model or something like that. But if you're looking at a different type of concept, like gender or something else, we don't have like kind of very extensive results on this, but like we tend to find that it's not affecting performance a whole lot, just because it is a surgical modification, and you're only erasing like one kind of dimension out of the like thousands of dimensions that exist in the representation.
Yeah, because I think we're going to get on to talking about your stats paper, and there's some interesting results there that the neural networks, given enough computation, can start to learn some incredibly bizarre and interesting statistical features. Does that in any way negate your work here?
Sorry, does it negate the LEACE work, or?
Well, yeah, so if you surgically remove concepts that we know about, but the neural networks still have this uncanny ability to learn esoteric, weird statistical proxies all over the place at high frequencies and so on. Does that imply that when we train these huge neural networks, that it's almost a difficult thing to do to kind of surgically remove what we understand to be concepts?
There are definitely limitations to LEACE. And we have seen that. So I mean, the big limitation of LEACE is just that we are removing linearly available information, but obviously, deep neural networks are non-linear. There is some kind of interpretability research suggesting that, well, even though networks are non-linear, it seems like They do use linear representations in many cases, but nevertheless, like take CFAR 10. Okay, this is an actual experiment that we did, and you're treating the images themselves as like a target of concept erasure, and you're just erasing the class as a concept from the images, and then you try to train, and you do LEACE for that, and then you try to train a model on top of those images. Models can still learn to classify the images, right? Like it doesn't matter that you've removed the linear information. There's still higher order information there, and like they can find that without too much trouble. So the hope with concept erasure is, I guess it's kind of twofold. One is if you're targeting a concept that is not like super essential to the model's performance. Like it's kind of helpful, but like, and so it does learn it by default, but like, it's kind of an optional feature. Then, there's the hope that like removing the linearly available information will actually affect the model's behavior, and it will not rely on that feature as much as it would by default. That's one thing. The other thing is just that, honestly, I kind of forget what the second thing was supposed to be.
Oh, that's okay. I mean, because a thought is that LEACE is applied to every single, like a neural network is a whole bunch of nested kind of matrix transforms and then a non-linearity, and you apply it sequentially to every single linear component of the network. And I suppose I'm just being a bit naive here, but you might think that somehow does the non-linear thing because you're applying it throughout the network. But what you went on to do was, like a higher order version called QLEACE. And you also did some work looking at higher order information that is learned in these networks. So, but what you're saying is that the networks still learn this higher order information, and that can still learn some of these concepts, even though we've run LEACE on it.
Yeah, exactly. So, there's kind of a hope that if you erase lower order information, like linearly available information, or we might talk about this in a bit, quadratically available information, kind of second order information, it's still possible for the model to learn the concept using like third, fourth, fifth order statistics, but it's just going to be a bit harder, and the model may rely on this information less than if you did nothing. That's kind of the idea.
So you made a quadratic version of LEACE.
Yeah, right. So QLEACE is kind of a follow-up to LEACE, where we were like, okay, we want to make a form of concept erasure that is more thorough, essentially. And the way that we operationalized this is we were like, okay, we want to prevent not only linear classifiers from extracting information about our target concept, we want to prevent quadratic classifiers. So classifiers whose kind of output, like logits, are just quadratic functions of the input. And it turns out, you can like do some math, that is equivalent to making the means and covariance matrices of your classes equal. And we did some more math and showed that you can kind of achieve this equality of means and covariance matrices using tools from optimal transport theory. And yeah, so we like derived some more closed form solutions for QLEACE. And we started to do experiments with QLEACE. In particular, one experiment that we did was we looked at CFAR 10. So we're treating the images as just kind of representations themselves. And we're trying to remove the concept of the class label from the images. And if you apply just normal LEACE to this, it doesn't really have much of an effect at all. Like models can still learn to classify the images after LEACE very easily. It turns out if you apply QLEACE to the CFAR 10 images, and your classifier is small, so it's like 2 or 3, maybe 4 layers, like an MLP especially, then it actually can't learn anything, or at least in our experiments, which we haven't published yet. We still want to like, yeah. But at least in our experiments, we did some hyperparameter tuning for this. We were unable to get these kind of small classifiers to learn anything after we applied QLEACE. So we started to get excited about this, but there are some like big caveats here, because it turns out that if you look at larger classifiers, and if you look at, a large like convolutional neural network, like a ResNet 50 or larger, and then you try to train that thing on these QLEACE images, it actually backfires. Now what do I mean by that? Well, it basically, it turns out that it's basically a artifact of how we derived QLEACE in the first place. So with QLEACE, unlike with normal LEACE, you have to kind of look at the kind of value of the concept at inference time in order to apply QLEACE. So you need to like when you're applying QLEACE to an image, you need to like know, okay, this is actually an airplane, and then you like use that information to choose what transformation to apply to it. The problem is that when you're kind of peeking at the label, this actually kind of leaks information about the class label into the higher order statistics, the third, fourth, fifth, etc. statistics. And models, if they're deep enough, are able to pick up on this signal. And so you can get this backfiring effect where like you think you're trying to make the concept less salient or like harder to learn, but you're actually making it easier to learn. And so we kind of, that's why we haven't like done a QLEACE paper per se. And we would be, QLEACE has some applications, but they're kind of niche. We really think you should be careful if you want to use QLEACE. But these experiments into kind of CIFAR10 and like doing these transformations on CIFAR10 images led us into this kind of new direction of research that led into our ICML paper for this year. I'd be happy to talk about that as well.
Yeah, just a quick thought on that. In the olden days of interpretability, we used to talk about Shapley values and Lime and all of this kind of stuff. And it seemed infinitely tractable, that we could understand what a model is doing and we could manipulate it. And what you seem to be saying is that when models just become really big and complex, they just become inscrutable monsters, and all of our efforts get resisted because they always find a way to do what they want to do.
Well, that is definitely one way of thinking about it. I tend to be a bit more optimistic than that, but I do think, it is true that if you're, gradient descent is like a very powerful optimizer, and if you are trying to kind of directly go against gradient descent and like prevent gradient descent from accomplishing something, when there's just like a very strong, kind of, when you're trying to prevent gradient descent from like reducing the loss, like you're probably going to lose that battle. Especially if you are not applying kind of an equal amount of optimization power yourself, if that makes any sense. So yeah, I think that's part of the lesson from the QLEACE thing.
It's almost like another bitter lesson, but an interpretability bitter lesson.
Yeah, right. I think, some other interpretability people have pointed this out, but you probably don't want to like optimize against interpretability methods, or at least you want to be like very careful. And you probably don't want to like directly optimize some measure of like the interpretability of your model, because it could just like end up learning something that's like totally different from what you expect.
So stats paper.
Right. So there's kind of this big literature that, already existed before we did this paper on kind of simplicity biases in deep learning. So the general idea is just that, when you randomly initialize a neural network, it starts out as a quote unquote simple function. Now the question is like, okay, what is simplicity? What are we talking about here? There's a lot of different notions of simplicity. But, intuitively, like most randomly initialized networks are going to be more simple than the network that you get after training. And then, you start out simple at initialization and you kind of gradually get more and more complex. That's the basic idea. And there's many different papers kind of trying to flesh out how exactly this works. In what sense is the model simple and getting more complex? And our paper is sort of an additional contribution to this literature. So we were looking at it from the perspective of statistical information. So like in statistics, there's a concept of a moment. So the mean of a distribution is called the first moment. And then the variance and covariance between the different components of your data are the second moment. And then you can talk about like third order interactions between the components of your data. It's like a third moment and so forth. And basically our hypothesis, which kind of came from some of these QLEACE experiments, was that models learn to kind of exploit or use these statistics, these moments in order. So kind of early in training, the kind of predictions of the model are primarily going to depend on the kind of first order moment or just the mean of the distribution of the data. And then it's going to start kind of depending more and more on these kind of simple correlations, these, the covariance between the different components of the data. And then it's going to start using third and fourth order information later on in training. And the way that we actually kind of came to this hypothesis specifically is we used what's called optimal transport theory to take CIFAR-10 images from one class and kind of modify them so that their mean and covariance matrix match the mean and covariance matrix of a different class. And you can do that. You can like use this closed form formula from optimal transport theory to do this in a way that kind of keeps the images that basically changes the images as little as possible. It's very similar to LEACE. It's kind of a surgical edit to the images that like just changes their mean and covariance and then keeps everything else as similar as possible. And if you look at the images, which you should definitely look at, you can barely tell the difference like before and after. Like, there's in our paper, we've got an image of like an ostrich, and we like change it to be an airplane and change it to be a deer and change it to be a frog. And it's, you can see a little bit of differences in the background, but it's like almost the same image. So to a human, this is like not changing hardly anything. But it turns out that if you do this transformation to models early in training, in the first, few thousand steps or so, they get fooled, basically. So like they're gonna, early in training, image classifiers are, very likely to classify an ostrich that has been edited to look like an airplane from the perspective of second order statistics. They're very likely to just classify it as an airplane. And we quantify this in the paper.
Yes, I was going to ask why you can make these modifications, and to the human eye it still looks the same. And I'm an experienced video editor, and I know that you can modify the distribution of values. Like it might be recorded in RGB format, and you can squash and you can translate and you can kind of move things all around. You can change the mean, and visually it still looks the same. Maybe you just changed the luminance values or something like that. So the weird thing is that you can make it look as if it's a different thing to a machine learning algorithm, but from a human perspective, it still looks the same.
Yeah, exactly. And people have kind of pointed this out before. I mean, there's the whole literature on adversarial examples, where you can just change a few pixels in an image and it completely changes the class. I do think that there's like a different mechanism going on here. It's not just because, for example, we're not actually optimizing against the network. So it's not adversarial in that sense, but it is showing that, especially early in training, these networks are sensitive to, simple features that humans are kind of much less dependent on.
Yeah, that's fascinating. So there's this unraveling of complexity, to use GPT language, that early on it kind of focuses on very simple things. So it might be looking at the statistical moments, and then as you continue to train the network, it starts looking at increasingly kind of complex, inscrutable features.
Yeah, exactly. And we show that in our paper. There's kind of this graph where the x-axis is time, just like the number of training steps. The y-axis is the accuracy, where the accuracy is measured with respect to our kind of target labels when we're applying this concept editing or optimal transport theory. So we're like showing it the ostrich that's supposed to be an airplane and saying you should classify this as an airplane. And the accuracy gets to, like 40%, 50% in some cases at around like 1,000 training steps. And then it starts to go down, right? I think at the end of training, it's still above 10%, which is kind of interesting, at least on CFAR 10. But yeah, there's kind of a non-monotonic process where it starts out random, then it gets kind of fooled by our thing, and then it gets smarter and stops being fooled as much.
Yeah, it's so interesting. So simple features are easy to guard against and they're intelligible to humans. And it raises the question of, do we actually want neural networks to learn very complex features? I mean, would it not be more ideal that we guard them so that they can only learn simple features that we understand? And, Occam's razor, right? Aren't simple features more robust?
Yeah, right. So I think, it's going to depend a lot on both what you mean by simple and the kind of the task at hand. I do think, broadly speaking, simplicity is like a good heuristic, and like the sort of literature on simplicity biases and deep learning does tend to say like, okay, this is the explanation for why models generalize, right? Like if they didn't have any kind of simplicity bias and they just started out incredibly complicated from the beginning, they would probably overfit or they would just not do well at all. And so you need some sort of inductive bias like this. There are different ways to have inductive biases, but you definitely need something.
And why is that? What you said is really interesting. So it's almost like it's an inductive prior, that the neural network starts learning simple functions and then it almost branches out into increasingly complex functions, almost as if it wouldn't be possible to get to the complex functions unless they started with the simple ones. But the counterexample is something like grokking, where they seem to make this transient change, into a completely different type of function.
I've looked into this a little bit. I wouldn't say I'm like an expert on the grokking literature, but I do think people tend to like overestimate how fast grokking happens. There are some like plots that there are like certain papers where it like kind of, there's like a plot that's kind of demonstrating the grokking phenomenon, and it kind of looks like grokking is happening really fast, but actually if you look carefully, the x-axis is on a log scale. And so really the grokking is happening like over, like at least half of training or something like that. But yes, grokking is an interesting case because it's precisely because it's an exception to the rule. It's an exception to the rule that you tend to start out simple and get more complex. In cases where grokking happens, usually it's because there's something like weight decay or some other regularizer that's being applied that is like, encouraging the model to kind of get simpler over time. And there was one paper that I read a few months ago that applied the neural network tangent kernel to this in a way that seemed pretty compelling to me. Maybe we can like find it later and put it in the description, but it is an interesting topic.
Cool. And just final question on, high frequency features in general. I mean, there was a great paper many years ago, it might be by Whelan Brendel, talking about how vision models tend to overfit on textures. So they don't learn a cat the way we do. They look at a certain texture of cat fur. And this makes neural networks have really good performance. So there seems to be this trade-off between, well, should we stop the neural networks from overfitting on cat fur?
Yeah, I don't know. I guess in the case of image models, I mean, I would tend to think if an image classifier is able to overfit on cat fur, as you call it, and kind of focus on textures and not on shapes, and is still getting good performance on benchmarks, that kind of suggests that maybe the benchmarks are not as good as we might hope, or they're just kind of, I do think that, like, if you want to build, an autonomous robot or something like that, you probably will need a computer vision system that has more of a shape bias and is a bit more robust than a lot of these CNNs that we've been training.
Can you distinguish meaning and value? Because I kind of bucket this conversation in my mind in the broader discussion around what is value.
Yeah, I mean, they're definitely closely related. I guess I think meaning it is a bit more individual, even though it's about being connected to something bigger. But it is kind of it is sort of saying, like, okay, like, does this person have meaning in their life? Whereas value is kind of a broader concept that isn't necessarily, like, individualistic. If that makes any sense.
How is meaning related to purpose?
A lot of people will talk about, like, the meaning of life, right? And you might kind of rephrase that as, like, the purpose of life, meaning of life, purpose of life. These seem like kind of similar. In both cases, you're sort of looking for something almost external to life, perhaps, or this life. A lot of people think that their meaning, like the meaning of life to them, is like the afterlife. It's God. It's something kind of supernatural and external to this life. Of course, not everyone has that view, but that's, like, a common view. It's sort of like, if you think that, like, life has a purpose or has a meaning, you might think that life is kind of instrumental to something else. It's like, this life is just a journey to get to something else or whatever. Whereas I tend to not like that type of view. And I think I think we should not try to kind of make life instrumental to something else or something external, in part because we have no good reason, in my opinion, to think that there is something external. But even if there is something external, like, I think we should be looking for meaning in life itself. We should be looking to kind of live in such a way that we can be satisfied and find meaning just in the everyday, in what we, our day-to-day interactions and our hobbies and so forth, and not because we think it's all kind of culminating up to something greater, in the future or for future generations even. It's sort of a Zen view.
Interesting. So it sounds a bit like you're saying meaning is related to individual or perhaps collective joy.
Yeah, I think it is related to that. Although I wouldn't want to just reduce it to, like, feeling happy. That's probably part of it, but it's not just like an emotional state.
And what's the relationship between meaning and goodness?
I mean, I would say that goodness is broader. I mean, goodness is it's a very broad concept that's just kind of pointing to, like, anything that you think is valuable, anything that you kind of feel motivated to promote or something like that. And so, meaning is good by definition, probably, or, like, at least in the way that I'm defining it, like, meaning is good by definition. But, like, maybe there's, like, other things that are also good.
Do you think a sort of Panglossian perfect simulation machine, like the what do they call it? The experience machine, is that good?
Yes, that's a really good question. I think it depends. For me, it depends on whether there are like other people in the experiments machine with me, basically. If we're like kind of if there's like millions of people all living in an experience machine having relationships with one another, I'm not necessarily opposed to that. I mean, it might depend on the details, but in a way, as we develop our technology to kind of make our environment more comfortable for ourselves and like, make it easier for us to just exert less effort to kind of like make things the way that we like, we're kind of gradually moving toward like a collective experience machine, right? We're just, and then like virtual reality is like obviously one step further in that direction, but like it's all kind of just like, yeah. So I'm not necessarily opposed to experience machine type things, but if it's like just me in an experience machine and there are no other people in with me, or like all the people there are actually like just fake and are not actually like autonomous conscious individuals themselves, then I would probably oppose that.
What's the relationship between meaning and consciousness?
Yeah, so that's a big question, obviously, and it's one that I've been thinking about a lot recently. At least the way that most people think about consciousness. Conscious. If something is conscious, then that at least kind of strongly suggests that it might have moral worth, or it might, because if something is conscious, then it is probably capable of like pleasure and suffering, having like experiencing good or bad states of consciousness. At least like all other things being equal, like it's like probably good to like help that being kind of experience better states of consciousness. Um, I I don't necessarily kind of reduce all goodness or value to states of consciousness. That's sort of the utilitarian perspective. But I do think that it is like a big chunk of what I value. Um, yeah.
Do you think you need consciousness in order to have moral status?
Well, it may depend a little bit on what you mean by moral status. I would be inclined to say no, just because like if I thought about it, there would probably be some counterexample or something like that. I'm like hesitant to make like a blanket statement, but I guess maybe I'll just say, I mean, like some people think that like nature itself, like a mountain or maybe a tree or something, could have moral status without being conscious. And I don't know, like I think that's like at least somewhat plausible. I'm not sure my exact view on that. But anyway.
Do you think there's more meaning in a globally connected world or a locally connected world? And just to make the question not completely obtuse, I mean, you could become a big entrepreneur and you could be like Bill Gates or something, or you could just have intrinsic value in your local community and doing the garden and stuff.
I don't know. I guess I tend to think like connectedness is good or something, or like unity is good. But I also, yeah, I don't have a strong intuition though.
Well, do you think echo chambers are, like, is it good to have a diverse group of pockets of different people doing their own meaning making, or are you more of a homogenous person?
Yeah, I mean, I definitely have like the intuition that diversity is good, and actually, it, this kind of makes me think of something that's just been on my mind recently in Vienna, because, of course, Vienna is like a German speaking city, but English is like everywhere. And actually, a lot of times people will just kind of use English by default. Like even if they like don't know where you're from, they'll just like use English. And I take it that like a whole lot of cities these days that are not traditionally English speaking, like are kind of like that now. And I feel conflicted about it, because it's like, okay, on one hand, like English is this like lingua franca and it's enabling people to communicate with each other, and that's great. But there is part of me that's like, I don't know, like if we keep going on this path, and it's like, is anybody gonna be speaking German in 100 years? Like, I'm not sure, and I feel like that it seems like you're kind of losing something if that happens. But
Yeah, yeah. I mean, so we should preserve, local culture, situated knowledge.
yeah, I definitely feel like that is somewhat important. And I guess maybe one of my hopes for the future is that with AI and the automation and abundance it'll bring, that people will be able to kind of preserve and enhance their own kind of like autonomy and local quirks and stuff, like because people just have more time and kind of resources to just keep doing useless things. Um,
You just said something very interesting, which perhaps we should have highlighted earlier. You're an AI optimist, and you said that it's going to bring abundance. What did you mean by that?
I mean, I think that, in the next few decades, like AI will come to be like at least as good or better than humans at like basically all the jobs that humans are currently doing. And this will enable, if things kind of go right politically, which they may not, but this will enable kind of a society of abundance for everyone, where we don't really have to work for a living, whether it's through like a universal basic income or just people have investments that are enough to live on or whatever. And yeah, so I definitely I am hopeful that in many ways the future will be like much better than today's world. But I also I do want to recognize that like there's also many ways that things could go wrong as well, and I think we're probably in for a bumpy ride.
Interesting. Can you expand on that a little bit more? So, why do you think that we're on the path to presumably agential superintelligence?
I mean, there's like a few different arguments you could make. I mean, one of them is just like super high level, like, well, technology is just continuing to improve, and like, there's no like, doesn't seem like there's like a physical law saying that you can't build super intelligence. So like, we're probably eventually going to get there. And then you can look at like progress, recent progress in AI, and it seems like, you can debate on like the exact timelines. I actually don't have super precise timelines. I wouldn't say like, oh, within 3 years or within 20 years or whatever. I'm not really sure exactly how fast progress is going to be in the coming years, but I guess I don't anticipate like a super, I don't anticipate like a plateau in like a really strong sense. Like I think we're probably going to continue seeing AI progress, and it seems like if it continues just at roughly the current rate or like within an order of magnitude even of the current rate, like we'll have very powerful AI and very versatile AI like within my lifetime.
Just devil's advocate on that. I mean, there are those who say that current AI is basically a pseudo system one, and it's getting better because it's just memorizing more and more of the long tail. But, reasoning, which is to say deriving new knowledge, kind of intrinsically in the model to achieve a goal or something like that.
I do take issue to some extent with the people who say, current AI doesn't reason, period, or something like that. I think part of the issue is that it's sort of a terminological question. It's just like, well, how do you define reasoning? How do you define planning? Like, depending on your definition, like maybe they reason, maybe they don't reason. And I'm not sure if it's useful to like debate that, or I don't know, to kind of go back and forth on that terminological question. I think even if you concede that like, oh, there's serious kind of barriers ahead where like we're going to need to come up with like some sort of a new architecture, new paradigm or something in order to get, system 2 reasoning or something like that. It's still kind of hard for me to imagine that will delay progress so much that like it'll be like 2100 and we still don't have like AGI by whatever definition you care to use. I think that's like the thing that I'm most confident about. Like at the longest, like if it's 2100 and we still don't have AGI by like like everyone's definition, then I'm like very surprised. I think it's probably earlier than that, but like yeah. And if it's 2100, I still feel like that is soon enough to like be thinking a lot about. And like I said, it's probably earlier, but
What is your definition of AGI?
right. So I don't. Maybe I shouldn't even have brought up the term, because I tend not to like the term, just because it's kind of vague and broad and people have different definitions. I mean, maybe the definition that I kind of like the most, just because it's broad, is just like an AI that can do many tasks or something like that. And so like generality is just like this continuum, and you can just have AIs that like do more and more tasks. And then by this definition, like GPT-4 is already an AGI. It's like general in the sense that it does many tasks. It doesn't do all the tasks that humans do, obviously, but it does many, many tasks. And so it's a general in that sense. It's kind of a deflationary definition, which is why it might even like kind of annoy some people, because it's like it's clearly not what like other people mean when they say AGI. But
you would concede right now that that it's inefficient. There's an insane amount of computation required, but in principle, we might be able to design it better.
yeah, I think that's true. And there's some interesting work actually on like data efficient AI. And I'd personally like to read more into this, because I've only read a little bit. But there was, I believe, like a contest recently where people were kind of challenged to like build language models that are like as efficient as like a child or something like that. And I don't think they got all the way, but like there actually was a lot of progress. And I believe one of the top kind of methods in that contest was just in part to use a lot of epochs. So like currently, like with language models, we usually only do one epoch on the training set, just because we can afford to do that. Like there's just so many, so much text on the internet that like it's better to have more data as opposed to like less data and then do more epochs on it. But if you do more epochs on the same training data, like with some tweaks and regularization and stuff, you can get like a lot out of less data, it seems. So yeah, there's still work to be done on that front.
I know you're a fan of for recognition.
Yeah.
Tell me about that.
Yeah, so it's still a thing that I'm learning more about, but the idea of for cognition or for cognitive science is the idea that the mind is enacted, embodied, extended, and embedded. I definitely said that in like the wrong order or something.
Oh yeah, it's the ecological. So the extended one is the one that Chalmers and Andy Clark snuck in by the back door.
Okay, well, right. So I understand there's like a debate about this, whether extended counts or whether it's ecological. But I guess the way that I like the extended mind thesis, so I tend to include it in there.
But even that's interesting, isn't it? Because the extended version is still a form of representationalism and computationalism, which the 4E folks said that they didn't like, because they fundamentally believe that you can't simulate a living thing in silico.
Yeah, so there's a lot there. I mean, I guess one thing I would say is I don't, maybe for the audience, like the extended mind thesis is just the idea that like the tools that we use, like computers or notebooks or all sorts of things that we use to kind of enhance our cognition, are like literally a part of our minds, or like it's like useful to view them as part of our minds. And I guess for me, I don't see why the extended mind thesis assumes computationalism or representationalism. I think like you could be a computationalist or a representationalist about cognition and accept it, but like you also don't need to believe those things.
I have to be honest with you, Nora, I think I agree. So I think we might be strange because we are big fans of the 5Es.
Yeah.
And we both believe that you can talk about all of them in a computationalist sense. So, for example, we were just talking about the guy who wrote Mind and Life, Evan Thompson. So he's an autopoietic and activist. Tell us about him.
Yeah, so Evan Thompson is a pretty cool guy. He's a philosopher, and at least I'm not sure if he calls himself a cognitive scientist, but he like works with cognitive scientists. And he has been kind of behind a lot of these ideas of like embodied cognition and active cognition, etc. So me and Tim over the past day or so have been talking about this position that Evan has that basically life is inherently material. So like you couldn't have a living thing in a simulated environment, even if the simulated environment were like very detailed, for example. He's got sort of another argument for this position, which is basically that he thinks that computation itself is observer relative, or that computation, algorithms, simulations, all of this stuff, it's all sort of dependent on some observer, or some agent, some living agent, I suppose, who is using the computation and kind of interacting with the computer and using it for certain purposes, and thereby kind of imbuing the computation with meaning, etc. And without the observer, without the living agent, computation is meaningless. It's not even computation at all. And so, based on that view, he's like, okay, look, if you try to simulate life in a computer, it's not really life in like the full sense of the word, and it also wouldn't be conscious. It wouldn't be sentient. It wouldn't genuinely have feelings or anything like that, because it's it's we who are kind of like giving meaning to the simulation. Whereas for Evan, life is kind of unique in that it gives itself its own meaning. So like genuine life, in the real material world, is autopoietic. It creates itself. It's like kind of actively reproducing itself and thereby creating meaning. And so you can't have that in a simulation, because the simulation is always kind of by definition having meaning given to it from the outside. That's the argument. I think both me and Tim disagree with this, or at least I'm very doubtful of it. And I guess my main concern with the argument is that, so I accept the idea that computation is kind of observer relative. It gets meaning from like being used by some agent, but it sort of seems like that's true for almost everything. That like the whole world, or just like material objects, are sort of, we're always kind of interpreting and kind of, and there's actually part of Evan's kind of own philosophy of enactivism that like the world and the mind are kind of co-created together in this process of living. And so it's not really clear to me how he can consistently have that enactivist view about everything, about the whole world, saying the whole world, the world is created by living things in a certain sense, but then kind of single out computation and saying like, well, no, simulated worlds aren't really real because they're dependent on living things for their meaning. Because it seems like he's saying that everything is dependent on living things for their meaning. And in this, I'll just say one more thing. There's an interview where he kind of talks about this with Richard Brown, I believe. And he himself kind of recognizes that there's a tension in his own view about this, that, maybe you could just, he's trying to draw a distinction, but like maybe you can't really draw that distinction because, anyway.
Yeah, we listened to that interview earlier. I think it was about 3 years ago that he did that. If I understand correctly, he's still a materialist, but he's kind of a material chauvinist, and I don't mean that pejoratively. But what he's saying there is that you can simulate things, but there's this kind of semantic graph of meaning. And as you were just saying, almost per Wittgenstein, this is what Mark Bishop said, the meaning of a computation is in its use. And you can always trace back all of the edges on this graph until you get to material. So he's saying that there are things in the real world that exist even without observers. They have a kind of primacy. And so obviously the first argument he's making is the basic one, which is that a simulation of fire doesn't get hot. And then his slightly more nuanced argument is that only things in the real world can exist without observers. And I don't know, it just seems a bit strange, right? Because we have this qualitative experience and we have meaning and so on, and we could be in the matrix.
Yeah.
So why do we feel that we're so special?
Yeah, I think that is a genuine objection. I mean, because it seems to me like, no matter what you think about like the simulation argument or the matrix, like how probable it is, it seems to me like we could be in a simulation. Like we don't have like a priori like certainty that we're not in a simulation. Like, and similarly, like it could just turn out that, if you crack open my skull, there's actually like silicon chips in here, and like subjectively, I wouldn't like know the difference. And it just seems weird to like be like, I know there are philosophers who actually say, well, we know we're not in a simulation because the simulation can be conscious. Like that's actually a view that is out there that philosophers hold, but I don't know. I just have a pretty strong intuition that like that's just being unjustifiably confident, I suppose. I don't know where they're getting this confidence. And yeah, there's also kind of a weird thing too. I don't think Evan Thompson believes in God, but if you did, it seems like, okay, is he going to say that like if God exists, then like we're all zombies or we don't have meaning because God is kind of, like traditionally God is sort of thought of as like almost playing the role of like the simulator of a simulation. Even if you don't think that it is a literal computer simulation, God is kind of like giving meaning to everything. He like created everything. He had a design for everything. And it just seems like a weird position to say that like if God exists, then we're zombies or something like that. So, yeah.
Yeah, how would you distinguish Evan Thompson's argument just from a standard eliminative materialist physicist? Does he think consciousness comes higher up, or does he think it starts quite quickly?
So in his book Mind and Life, which I've read the first couple chapters of, I'm still getting through it, but so to the extent that I understand his position, he actually does come at philosophy and metaphysics and all of this from a fairly different perspective than like certainly most like naturalists or kind of eliminative materialists or illusionists, whatever you want to say. Because he starts from what's called phenomenology. And phenomenology is this kind of, branch of philosophy that was started by Edmund Husserl in like the I think it was like late 1800s, early 1900s. And then was kind of Heidegger and then Merleau-Ponty all kind of continued this line of work. But the basic idea of phenomenology is just like we start our philosophical inquiry with our lived experience, our embodied experience, as Merleau-Ponty would like to emphasize. So they say like, okay, look, the things that we perceive, I perceive my body, I perceive you, I perceive this room, all of this. It's the realest that anything can be. It is kind of our starting point for philosophy. And then from our lived experience, we then start to make, philosophical and scientific theories that allow us to kind of understand and kind of predict and control our experience better. But fundamentally, like, lived experience is kind of the foundation of everything. Um, and so from that perspective, he's definitely not going to say that, like, consciousness is an illusion or doesn't exist. He does have a different perspective, a somewhat different perspective on, like, what consciousness is, from some other philosophers. But yeah, he does start from kind of experience or consciousness. And usually the people like Dan Dennett or Keith Frankish or some of these people who are kind of more hardcore materialists, are not starting from lived experience. They want to sort of say, well, maybe we don't need to start from anywhere, or it doesn't, or we start from science or something like that. And then because they're sort of starting from science, they just say, well, we can't really make sense of, like, the consciousness thing, so we're just gonna just forget about it.
That sounds like it's quite similar to idealism, that the stuff of minds is fundamental. And even then, there are kind of subjective and objective versions of idealism. But would you kind of put him in that bucket?
So I definitely think Evan would. I'm fairly sure he would not want to be called an idealist. Within phenomenology, there is sort of a tension, and different phenomenologists have had different sort of ways of thinking about what experience really is. I think Edmund Husserl might have been more close to kind of an idealist perspective. He was famous for this idea of the epoche, where basically you're looking at your experience, you're describing it, but you try to refrain from assuming that your experience is reflective of some objective reality. You don't want to say, like, oh, it's not reflecting our objective reality. You don't want to assume that either, but you just want to kind of withhold judgment about whether there's an objective reality behind it. And so that sounds a bit more kind of like an idealist approach, where you're like, well, it's just this experience which is, like, kind of mental or something, and it may not correspond to objective reality. But other phenomenologists like Heidegger or Merleau-Ponty are usually seen as being less idealist, especially Merleau-Ponty. He really focuses on the importance of the body as kind of the vehicle through which you experience things. So he definitely wants to say that the body is real, and the body is not really a mental thing in the traditional sense. And he also has some interesting thoughts. He'll say that, like, our direct experience, like my direct experience right now, includes you as a person. It includes, like, a camera. It includes, these windows, and it includes, like, objects. He would say that, like, whereas a lot of people, when they think about idealism, or at least certain ways of thinking about conscious experience, they'll say that, like, well, your experience doesn't actually include people, windows, objects, because that's an interpretation of your experience. Your actual experience is just, like, colors and, like, raw sounds, like uninterpreted raw feels. And they'll say that's the thing that's real. The interpretation is, like, kind of fake or something. And that's, like, Merleau-Ponty wants to reject that, because he says, like, okay, look, the person on the street, or, like, before you started thinking about philosophy, you definitely didn't think of your experience as being about colors and raw feels. That's kind of this, the very idea that you're seeing raw colors separated from the objects that have the colors is this kind of post hoc kind of abstraction that you get from philosophical thinking. But, like, really what's there in your experience is just, like, objects that have properties like colors and stuff, but, like, the object is there and you kind of experience it directly. And so if you have that approach, it's less clear that it makes sense to call it idealism. I mean, maybe you still want to call it idealism, but it's more of it's a bit hard to categorize maybe in the traditional dichotomy of materialism and idealism.
Yeah, I think there are flavors of idealism which could be thought as realist.
Yeah, I mean, so I guess I like how John Vervaeke thinks about like the word real and the concept of reality. He says that real is a comparative term. So like it only really is meaningful to say that something is real as compared to some other things that you're saying are illusions. Like if you just say everything is an illusion, it's like, okay, I guess. I mean, maybe that, it's not really clear what, if you say everything's an illusion or everything's real, it seems like those are almost the same thing because you're not making any distinctions. It seems like you kind of, in order to make the concept of reality meaningful, you need to be able to make distinctions between, well, this is real or more real than this other thing. And so it's kind of a matter of degree and a matter of comparison between things. So yeah, I don't like kind of hardcore like reductionist or materialist views that want to say that like, well, the only thing that's real is like quantum fields or like particles or something like that. I mean, you can say that, but it's like, what is the point of saying it? Like, I don't know. It just seems like you're kind of trying to be edgy or something, but like it's not really it's not a useful way of thinking about things anyway.
In Dennett and Frankish, when they talk about illusionism in respect of consciousness, what do they mean?
Yeah, so I think honestly the term illusionism kind of frustrates me a bit, like the word itself, because a lot of people, when they hear illusionism, they think that what illusionists are saying is that consciousness as a whole doesn't exist. No one has ever been in pain. No one has ever experienced anything. That's not what they're saying, at least. I mean, maybe some people would, what they say is, no, people have experienced pain. People have, experience exists, consciousness exists. It's just not what you think it is. And Keith will say that qualia, this like particular philosophical notion of consciousness, is not real and is an illusion. That said, so I don't like the term. I do also think that on the substance I disagree. I think, Keith Frankish in particular, and some other illusionists, well, I know at least some illusionists will say that there is nothing that it is like to be you. They want to reject the like what it's like talk. And they have like some arguments for this based, because they'll say that like, oh, you're always interpreting your experience and like what it's like to be you just depends on how you're interpreting it. And so there's no like objective interpretation. There's like different arguments like that. But I think those are all just kind of sort of non sequiturs, or are, I think, yes, you can interpret your experience in different ways, but that doesn't mean it's like unreal. And this sort of gets back to just like the kind of overuse of like the term unreal or illusion. I'm just like, why are you saying this? Like, what is, I don't know, like, what is this? How should I live differently if I think that like this is unreal or something? I don't know. It's not really clear.
Yeah, and whenever you try and make these arguments, you get accused of being a dualist very quickly, as John Searle was, and Thomas Nagel, who came up with this term, what is it like to be? He was also accused of being a dualist. But it's really difficult, isn't it, to talk about this qualitative experience in any kind of meaningful way.
Yeah, so there's this notion that like, qualitative experience is like ineffable, or that's like a term that people often use. I mean, in a certain sense, this is like obviously not literally true. Like you can try to describe, I can describe my experience right now, but what they're saying is like there's, you're always going to be missing out on some quality of your experience. You can never like fully describe it. And I mean, I think that's true, although I think I kind of want to extend that to like almost everything. I kind of want to be like, well, yeah, so like experience is ineffable in the sense that there's always, you can't like fully describe all aspects of it. But that's kind of true of everything. And that maybe that sort of ties in with my sympathies with phenomenology, as I was talking about before. Like, if you start from lived experience as kind of like the ground of like everything else, well, like, yeah, lived experience is like, not fully describable, but then like that's the ground of everything else. Like, nothing else is like fully describable. But anyway, that's kind of how I think about it.
So you wrote an article recently. I think it was on Less Wrong. Is that right?
It's cross-posted on Less Wrong and on optimists.ai. And I should say, Quentin Pope also co-authored with me. Counting arguments provide no evidence for AI doom.
Give us the elevator pitch.
Yeah, so there's this, there are a lot of people who are worried that AI will cause an apocalypse, kind of take over the world, kill everyone, something like that. And there's kind of an argument that is sometimes used for this conclusion. It's really kind of a family of different arguments that are all sort of similar, and it's kind of hard to pin down, actually, which is something we realized after we wrote this article. We kind of like proposed, okay, here's what we think the argument is, and then people later were like, oh, well, you like misinterpreted us, and so it's hard to pin down exactly, but the something like it is this. When you're training an AI to be nice and aligned or whatever, you're trying to make a super smart AI that cares about people and has your best interests at heart, etc. That's what you're trying to do. But there's this assumption that, okay, the AI is going to have a goal. It's going to have like some like overriding goal that explains its behavior. That's already sort of an assumption, which I might question, but that is kind of built into the argument. There's like some goal that is kind of describing its behavior overall. And then they'll argue, well, okay, there's like many different possible goals that the AI might have. There's like, infinitely many, or like trillions of them, or something like that. The AI might genuinely want to help you, but it might also want to maximize paper clips, or it might actually want to convert everyone to Mormonism, or whatever. Like, it could be anything. They would say it could be anything anyway. And they'll just say, well, look, most of the goals that it might end up having would motivate it to act aligned, like pretend that it cares about you. It like really, it's really aligned. It most of those goals will motivate it to pretend to be aligned without actually being aligned, because like its real goal is to convert everyone to Mormonism or whatever it is. And so the idea is like, okay, you're gonna have this deception. The assumption here is that it kind of understands that it's in a training process, and so it'll like recognize, okay, I gotta like play the training game and pretend, that I'm doing what the humans want me to do. And then when it kind of finds an opportune moment, it will strike, and it will kind of like take the opportunity to, kind of get out, remove any kind of safety precautions were in place that were kind of like sandboxing it or whatever, and it'll like escape and kind of take control of the government or whatever. It'll do whatever it wants to do. So fundamentally, the argument is based on there are many possible goals that would all motivate it to act aligned, to pretend to be aligned, but like very few of them are actually aligned goals. Okay.
So it sounds a little bit like, with instrumental convergence, it's saying that there would be many intermediate sub-goals for outside goals. This is like saying that there are many, many goals that would actually produce deceptive goals.
Yeah, many goals that would produce deceptive behavior, yeah. So
But does it also imply that the deceptive goals, like instrumental convergence, implies that the instrumental goals are kind of fewer and quite standard, like power seeking? Is it a similar case here?
yeah, well, so the idea is, so you've got like a terminal goal that like motivates all of your behavior, and then you can have instrumental goal, and so yeah, there is kind of an instrumental convergence claim kind of built into this, that like deception, like you could view deception maybe as an instrumental goal in itself or something like that, and like power seeking would be like an instrumental goal or something. Yeah, so in a certain sense, it is kind of a repackaging of other arguments that have been put forward before. But yeah, so in the article we give a variety of kind of rebuttals or counter arguments to this. So our first critique is like, okay, look, this general line of argument can't possibly be reliable because there's this other argument that is like almost structurally identical to the original argument that has an absurd conclusion. The absurd conclusion is that basically almost all neural networks will overfit to their training data and never generalize at all. Okay, so the argument goes, there are a very large number of functions, like possible functions that the neural network could learn, which would all be consistent with getting like low loss on the training data. Okay, but almost all of those functions would do terribly on the validation set or on some other distribution or whatever. Therefore, you should expect that like almost all the time when you train a model, it will learn one of those other functions that do well in the training set but like do terribly outside of the training set. Therefore, you should expect almost all neural networks to overfit. Okay. Now, clearly this doesn't happen. I mean, overfitting is a problem. It's not that it never happens, but it doesn't. It's not like it always happens in this extreme sense that would be expected by, or like be predicted by this argument. Of course, there could be counterpoints to this, and we could get into that if we want. But we're then like, okay, well, wait a minute. So why is this general argumentative structure unreliable or wrong? Like, what is actually going wrong here? And we point at a couple different problems with it. One problem with it is that it relies on this philosophical principle called the principle of indifference. So the principle of indifference, it might be easiest to use this like simple case. So if you just have a coin with like two sides on it, and then you ask like, oh, what's the probability that it's going to land on heads, and then what's the probability that it's going to land on tails? The principle of indifference says, well, you should kind of like assign like 1/2 probability to the one side and 1/2 probability to the other side, because there's only two possibilities and you have no reason to like prefer either like one or the other, so it's 50-50. Okay. So, it's an intuitive principle, and I think it gets its intuitive plausibility from cases like a coin or a die with like 6 sides. You're going to assign like 1/6 probability to each side. But I think this is actually it's a subtly fallacious argument, because there's kind of a different way of applying the indifference principle that would get you a wildly different result. And so it goes like this. If you flip a coin, you can think about the outcome of the coin flip as binary. That's like how we did it before. You could also think of the outcome as being a 3D orientation of the coin flip. That's actually kind of like a more reductive materialist way of thinking about the outcome of the coin flip, right? Because it's like, really, it's just like a material object that's got a certain orientation, and we're like imposing this interpretation of heads, tails on it, but really it's just like an object, right? So maybe what you want to do is you want to say that the outcome is this like 3D orientation, there's like an angle associated with like the x, y, and z axes or something like that. Well, if you interpret the outcome space as being the 3D orientation, then the principle of indifference would say, well, you should assign like every possible orientation should have like equal probability, right? But that's clearly wrong, because like that's like almost never going to land like on its side. It's not going to land in like an orientation that's like gravitationally unstable where it's going to like fall, right? So like clearly it's not the fundamental problem with the principle of indifference is that it depends on the way that you're like cutting up or interpreting the outcome space. And different ways of cutting up or interpreting the outcome space give you wildly different results. Maybe I'll give like one more example. So you could imagine there's like a guy named Bob where you know that he is in the UK or in France, or he's in like this geographical region of like the UK and France joined together. Okay, he's somewhere in there, but you don't know where he is exactly. Now, one question you can ask is like, oh, is he either in the UK or is he in France? Well, with the principle of indifference, you would assign like 50% credence to France or 50% credence to the UK, okay? But you could also cut up the like space of possibilities in a different way. You could say, well, he's in France or he's in England or Wales or Northern Ireland or Scotland. Or you could look at like, different like regions of France. You could like cut things up in a variety of different ways and you would get different answers. Like if you cut up the UK by like the different constituent countries, you would say that like it's like a 1/5 probability that he's in France and then like a 4/5 probability that he's in the UK, right? And I think this is, philosophers have kind of noted this for a long time. And I mean, there's still debate on like how exactly to respond to this, but it's generally agreed like you can't just apply the principle of indifference, willy-nilly. Like it's either just totally wrong or you have to be like very careful with how you apply it. Otherwise you're going to get like crazy results. And I think this is one of those crazy results. So I think that like basically the counting argument is it's assuming that you can kind of cut up the space of outcomes of the training process into like these goal categories or something like that, where it's like, okay, I mean, there's just like a variety of different problems with this. It's like, okay, so I'm like, one way of thinking about it is like, you're saying there's like discrete goals and there's like, a billion different goals. And then you're like randomly choosing from the billion different goals. Well, it's like, okay, first of all, it seems like really weird to assume that like goals are like discrete things, because that it's just going to depend on like how you describe the goal, and like that's just like really strange. Okay, so maybe you don't want to like describe the goals as discrete things. Maybe there's like a continuous space of goals, but like, fundamentally it's just, the problem is like you can describe the space of possible results of the training process however you want. You could describe it as either it's going to be aligned or it's not. It's 50-50, and then you would get a different, I think this is just a fundamentally unprincipled way of thinking about it. And, at the end of the day, if you want a more reliable answer for like how likely the AI is to be aligned, I think you should just not rely on an indifference principle at all. And you just need to look at, okay, the actual details of what's going on and try to like kind of come up with like a mechanistic understanding of it, and not rely on these like abstract principles.
Yes. This is related to my position on agency instrumentalism or agency illusionism, because you could argue on the one hand that goals are just not real, but you could also make the argument, as you have done, that there's significant ambiguity in how we represent goals.
Yeah, I think that's right. So there's a part of the article which I am like actually a little bit like, if I were rewriting the paper, I might the post, I suppose, I would rewrite it differently probably. But we do make this point that the counting argument seems to be assuming that like goals are real things that, they're so real that you can count them, right? Like, and like it's really true that an AI has like a particular goal and not some other goal, as opposed to viewing goals more as just like useful descriptions for kind of compactly describing behaviors. I still like mostly stand by that. I think that that kind of more doomy people, or people who kind of tend to use this argument, are reifying goals too much and are taking them too seriously, kind of as an abstraction. That said, I guess I think it would be easy to take this too far in the other direction and say, well, like goals are just an illusion, and I don't want to say that either. I mean, if goals are useful enough for us to keep talking about them all the time, like I want to say, okay, in some sense they're real or kind of real or something. So it's a tricky question.
Yeah, I've thought about this quite a lot. I discussed it with Philip Ball as well. I mean, my first intuition is that any intelligent system would have goal dynamism. Mm-hmm. So it kind of, it wouldn't make sense to think of this Bostromian super intelligence that had a single goal. And even if they did exist in the way we conceive of, we're talking about this big, inscrutable, intelligent thing. So surely the way we abstract goals might not be what the goals actually are. And it's also related to this intentional stance from Daniel Dennett, which is that we as agents, we adopt this stance, we build a model, we do abduction, and we understand what the rational behavior of another agent is based on our projection of what their goals are. But that is very much an instrumentalist view. It's just what we think the goals are.
Yeah, that is a good point. I mean, so Dennett has... I think most people interpret Dennett as being an instrumentalist about this, as saying, okay, it's just the intentional stance is just a useful way of thinking about agents. It's, we're just ascribing goals to systems, but like in some deeper sense, it's not real. But I think, this just gets back to like, how do we define real, and like what does it mean to say something is real or unreal? I mean, I do think, if something is like so useful to talk about that we're talking about it all the time, like you can't say that it's completely unreal.
Well, I think one useful distinction would be if it had consistency. So if it really is an inscrutable impulse response machine and it's just flitting from one goal to another dynamically, then I think it would be fair to say that it didn't have goals. The goals weren't real.
Right, yeah. And you could argue, I guess I'm taking sort of a pragmatist stance here. If the agent had, if its goals are changing all the time, then it might not be useful to describe it as having goals at all. Maybe it's better to just talk about patterns of behavior or something like that.
With this in mind as well, a lot of GoFi people and a lot of symbolists now, they think that the best way to design an AI system is to explicitly craft goals and maybe some kind of meta-learning system that creates sub-goals and so on. And I've always felt that this is mixing the description with the thing. So it doesn't make sense to build the description. You should sort of build the actual thing. I mean, what's your take on that?
Yeah, I mean, I guess I tend to take the view that like, I mean, I think I agree with you. I kind of like the analogy of like training a helpful and harmless AI to like kind of raising a child or something like that. Now you could like obviously take that like way too far, like that analogy way too far. But I think, when you're raising a child or like training an animal or something like that, you're not hard coding goals into it, or like it's not even really, you're usually not even really trying to like hard code a goal into it in the like Nick Bostrom sense of goal, where it's kind of like the single thing that's like motivating all of the rest of your behavior. You're usually just trying to kind of inculcate general kind of patterns you know, trying to inculcate general like values and kind of instincts and patterns of behavior, but it's not like inserting a utility function or something into the system.
Yeah, because this is relevant for alignment, because as you say, we bring up kids, we instill principles and virtues. And yeah, how does this help us with alignment? I mean, so one take would be we just we look at behavior alone and we just treat the system as inscrutable.
I guess I will say, obviously as an interpretability researcher, like there are things we can do with AIs that we can't do with kids or animals. We can look at their internal states, and we can kind of monitor them at a like very much like a much more fine-grained level of detail than we can with kids or animals. And that's actually sort of an argument that me and Quentin Pope made in a different post. AI is easy to control, but AIs are white boxes in a sense that animals and other people are not. They're just in the literal sense that we can just peer into it and see. It's because it's not like computer code that anyone wrote. It's not that like we can like rewrite the code, but we nevertheless have like a variety of tools that we can use to kind of peer into the AI and in some ways like see what it's thinking. We can train probes on it. We can look at for like language models, for example. There's actually another paper that I did on one of my first papers called the tuned lens. You can train these little they're basically like linear probes, linear classifiers at each layer of a language model. And you can see how its prediction of the next token changes from one layer to the next. And there's like interpretable predictions at early layers that are kind of relying on like simpler features of the input, and like it gets more sophisticated as it goes up. And there's like all sorts of things you can do like that. So that's all to say that like we have more tools. We have white box tools for AIs that we don't have for kids and animals. That said, I do think we can learn from the human and animal cases. Just one example is like people are now working on kind of data curation. When we first started training big language models, there was like very little curation of the training data. I think like OpenAI used Reddit Karma or something like that to like filter links, but it was like not, it was certainly not kind of like fine-grained curation. But what people are kind of trending towards now, especially for smaller language models, is to like, we're using a lot more synthetic data generation. So we're using like larger language models or older language models to generate data for the new language models. And we're also using AI as part of the dataset curation process to kind of, on a more fine-grained level, figure out, okay, like what sorts of things do we want our AI to see, basically. And, that is kind of similar to like how, children think about like, well, we want our kid to see certain things and not other things. And, kids are impressionable. AIs are much more impressionable than kids are even. And so, yeah, I think, careful dataset curation is like a huge part of alignment, I think. There are a lot of simple things that you can do that will go a long way.
Yeah, so there's like there's curating what goes in terms of data. And then there's this whole, there are many things like tree of thoughts and, RLHF and ways of behavior shaping on the output. And there are companies, for example, doing alignment systems where they explicitly craft goals. They say, this is the kind of goal we want. We want the company to make this amount of profit, and we want, this person to meet this performance target next year. And I feel that brutalizes the system for a couple of reasons. I mean, it introduces Goodhart's law, and there's the clever hands effect as well, so it might do the right thing for the wrong reasons. And I also feel that we need to have some kind of dynamism, to have an intelligent system. Like the system might need to do things that we can't conceive of in order to be successful.
Yeah, that's true. I mean, I guess there's different ways that you could try to kind of give a goal to an AI, right? So I think there's certain versions of this that seem more okay to me than others. I mean, like, I don't know, in a just any sort of organization, a company, anything like that, a lot of times, employees are given a goal, they're given a directive, which is basically kind of a contextual goal. It's like, well, we've got this deadline to finish this report, or there's certain quota for like sales, or whatever. Um, but and I think that's we do that all the time, and of course it does. It can cause problems, like if you have quotas, like they can be good-hearted or whatever, but like ultimately it does seem like these sorts of things are kind of indispensable, just breaking problems into parts and so forth. And I think one problem I have with these sort of some of these like arguments for doom is that they assume that when we give AI's goals, it's going to be this like the AI is going to kind of like take the goal in this very unnatural kind of like it's going to kind of like take it as its new kind of purpose in life, like everything. Okay, like you told me that I've got to like maximize, or I've got to like make some sales quota. Well, everything else goes out the window. That's like my only purpose in life. And if you try to change my goal now, I'm going to kill you because I only want sales and nothing else. It's like, that's not how humans work. And I also don't think that's how any plausible AI system is going to work. Like the way that people are starting to build, agentic, quote unquote agentic, like language models these days is not building in permanent overriding goals. They're just prompting, basically. They're like giving like, okay, in this context, like your goal is to do XYZ, but like, it does like, I don't think we should expect that the AI is going to like be so stupid and act in this like stupid and caricature type way where it just like forgets its common sense and realize and forgets that this is just a contextual thing that it needs to do, and it's going to be completed, and then it's going to be it should be ready for further instructions.
I wondered what your position on agency was. So, you have a language model, it learns a text distribution, so it's like n-grams on steroids. And then you do this RLHF, and you can do chain of thought and self-reflection and iterative prompting and tree of thoughts or fun search or alpha geometry, like all of this kind of stuff. And all of these things are placing significant guardrails on the kinds of trajectories that you sample if you sample it stochastically. So you're making it more and more domain specific to do a particular thing. And all the while, there are people who say, even in this setting, even though we've placed all of these guards on, it will have some kind of divergent agency, which is to say we're telling you to do this, but actually it has its own desires, if you like. What's your take?
Yeah, I definitely don't think we should expect like kind of emergent to agency or like autonomy from a system like this. I mean, that's in part because that's just not how we're training these systems. Like you could imagine like a very different world in which we were simulating evolution or something in our computers, and we were like, there's some sort of competition between different AIs and the ones that like survive, like it's like survival of the fittest or something. And that's how we got intelligence. Well, yeah, in that case, I'd be a lot more worried about like, well, they've got their own goals and drives, survival instinct, all of that. Then I would be a lot more concerned. But that's not how we're training them at all. It's mostly imitation, and we get to choose, carefully curate the data that we're asking it to imitate, and then we're, just kind of reinforcing behaviors that we like and negatively reinforcing behaviors we don't like. And I don't think that this kind of emergent autonomy stuff is going to come out of that.
Interesting. I think we agree. So we agree that if we create a high resolution simulation of the universe, then things like agency and intelligence are emergent properties, much like temperature is an emergent property. And we also agree that if you do this imitation learning in a language model with behavior shaping, and you wouldn't get agency.
I mean, I guess I'm just saying that I think sort of agency emerges in an evolutionary context, sort of like a Darwinian context, or, I mean, I guess if you're like trying really hard to make an agent, like maybe you could succeed at that. Like an agent in the sense of a system that has its own kind of self-interest and like some sense of like survival instinct or something, where it's not just kind of taking instructions from the outside, but it's got its own drives. I don't think that, yeah, like I said, I don't think, because we're not simulating evolution, I don't think we'll get that by default. And I also don't think there's really like an economic incentive to create that. I know some people disagree and say, oh yeah, there's going to be an economic incentive to create like, artificial creatures. But it just seems like at the end of the day, we're trying to make these AIs to do stuff for us. We don't actually have an incentive to make things that are uncontrollable, as far as I can tell. But
okay, but do you think that we could create an agential system which is still abstract and tractable enough to run on modern computers?
Yeah, I mean, I think that, like, for example, like mind uploading of humans is like probably possible with like some technology. I don't know, like, if it's like soon, but like that would, if you could upload like humans, then you would have like agentic systems with like self-interests.
Oh, would we? That's interesting that you think we would. I guess from an externalist point of view, I think that, a brain in a vat or a person in a hermetically sealed chamber wouldn't have much agency.
Yeah, so I guess we should separate maybe the like kind of behavioral question from like the more philosophical. So I'm not necessarily saying, I mean, we can get into this. I'm not necessarily saying like, oh, it would be conscious, although I think like it probably would. But I'm just saying we should be able to simulate humans, and humans are agents. And so behaviorally, you would have like similar concerns, like, well, like, does the human actually care about me, or are they just trying to like gain more power or whatever? And you could have all those worries all the while thinking that it's a zombie or whatever.
Yeah, I mean, I agree that we could, upload a whole load of minds and we could do a simulation of the universe and we could have virtual inter-agent agency in the simulated world. Mm-hmm. It seems like a step to have kind of like material virtual inter-agency.
Yeah, so I guess I'm also assuming that there's some, like, I guess I'm kind of imagining the world that's described in the TV series Pantheon, which people should watch. It's about mind uploading, and I mean, it's kind of a weird timeline, because like mind uploading happens before we get like just purely artificial intelligence that can do the same task. I feel like that's just not realistic. We're definitely going to get purely artificial things before we get mind uploads. But like the first thing, like they do mind uploading, and then they start using the uploads as slaves. Honestly, I mean, they're using them. I mean, they don't call them that, but like basically they're using them for like economic purposes. And obviously, in order to do that, they're connecting the mind uploads to the outside world. First, they don't use robots. Later, they do have robots, but they'll just, they'll connect it through the internet or virtual realities and stuff like that. And so there is interaction between the mind upload and the...
Wouldn't it be fascinating if we were in the Matrix, but currently we don't have any kind of control panel with the super simulation or the super world, but maybe the simulators were using us to just do financial trading for them or something like that. We had a little portal and we pressed some buttons on the portal. And as soon as we have that connection with the super world, we might start to express agency in the super world. So we'd start deceiving our simulators.
Yeah. It kind of reminds me of like a lot of weird speculations that people in Less Wrong have made about this is like a weird thing, but there's this idea of the Solomonoff prior or Solomonoff induction, where you're doing Bayesian reasoning, but you have a prior over the different hypotheses that is weighted based on Kolmogorov complexity, which is the length of the shortest possible Turing machine that would like simulate the hypothesis or something like that. And then the weird thing that happens if you imagine this is like, well, it looks like there are like relatively short programs for a Turing machine that would like simulate an entire universe. Of course, they would be like very slow. So like in practice, you couldn't, but like it's a short program. And so then it's like, if you imagine this, then you could imagine that there's like simulated worlds that have people in them that are like deceiving you, and then they're like they find out that they're like part of this Solomonoff induction process, and then like cause it to go in weird ways. Yeah, I don't think it like has any relation to like the real world, but it's just like kind of interesting thought experiment.
Yeah, so wasn't there a post on the EA forum which was called something like EAs want to maximize everything, but maximization is perilous?
Yeah, almost. So it's EA is about maximization, and maximization is perilous. Yeah, by Holden Karnofsky. And to be clear, in this post, Holden is not saying we should like, hey EAs, stop being EA, right? Because I think he still identifies as an effective altruist to this day. But he is pointing out that there's this real problem or peril at the core of the kind of effective altruist ideology. EA is kind of often defined or summarized as doing the most good. So it is about maximizing the good in some sense. But the problem is we don't really know what we mean by the good, at least in like detail. Like we have intuitions about like, well, it's, good to, save someone from a burning building. It's generally good to like reduce global poverty. There's like certain things that we think are like obviously good, but when you try to maximize the good, that's where you start to get into like kind of treacherous territory, because now you're trying to maximize something that you don't have a clear, crystallized kind of even formal definition of. And so it can lead to things like the whole kind of FTX debacle with where Sam Bankman-Fried and others went to jail for doing criminal, unethical things in the name of what they thought was doing the most good. They were trying to make money to in whatever way possible in order to donate it to effective altruist charities. And that was their interpretation of doing the most good. Of course, other EAs think, well, that's not what doing the most good is. But like they actually disagree about like what the good is. And when you're not maximizing the good, we tend to often agree about what the good is. Like, because we agree on the simple cases. We agree on, let's, give some money to this charity. Let's, whatever. But we start to disagree more as we push further out into like more and more exotic things. Like, oh, well, maybe the long-term future has like almost all the value because it's going to like last for, trillions of years. So many effective altruists have made this argument. And like, I don't know, like, is that like, people are just going to disagree on that. I don't, fundamentally, I don't actually think there's like an objective fact of the matter like built into the universe about what the good is. But what I think is that it's trying to maximize the good is just liable to lead to a kind of extreme behavior, more kind of disagreement and conflict between people. It's kind of, in a certain sense, it's like an extremist view, right? Like by definition, you're like going to the max. And so that's why I no longer view the good as something that should be maximized. I think we should be thinking about ethics much more in terms of like a virtue ethics, for example, where like the good is just, trying to be a good person, cultivating certain virtues in yourself, trying to be more honest, trying to be more generous or whatever. And not in terms of like trying to maximize something out in the world. I think that's a much better way of thinking about things. And so that's why I don't identify as an EA anymore. I'm not like hostile to all EAs or whatever. Far from that. I have many friends who still do identify as EAs, but I don't identify that way anymore.
Yeah, and it's not to badmouth EA. They do many great things. I think since the focus on long-termism in particular and AI safety, I think that's been a bit of an issue. And as you were saying, the two components are, as well as long-termism, this rationalist idea that you can reify goodness into some objective criteria. And that brings me to the next question. I mean, would you define yourself as a relativist? I mean, is that at odds with this idea that you can reify goodness?
Yeah, so relativism is a tricky word. So in one sense, no. So there's kind of a form of relativism which sort of says, basically, I personally think that I view all kind of value systems and perspectives as like equally valid or something. I think that's silly. I don't see a reason to believe that or take that perspective. It kind of leads to a weird sort of like, you're just kind of complacent and like you just think, well, everything's like, I don't know. It's sort of like tolerance taken to a very extreme level where you just like don't want to like criticize what anyone else is doing, and you're just kind of, so I'm not a relativist in that sense. There are like other senses of relativism, both about like morality and about other things, where I might qualify if you're saying that it's just, that like there are different, like I do think there are, that, the world, I mean, maybe this is kind of like a trivial thing, but like the world looks differently from different perspectives, and there are like just different ways of describing the world. And I don't think that there's like one uniquely correct way of describing it that like everybody must agree on or they're like totally wrong. I think like different just ways of talking, conceptual schemes, etc., can make sense from different perspectives. So maybe that like counts as a form of relativism, but it just depends what you mean.
Yeah, because we live in a globally connected world, and certainly the North American culture is very dominant. I mean, as a trans person, for example, you might not want to travel to Dubai.
Yeah.
And what's your take on that?
Yeah, I mean, so I definitely, I definitely don't want. I'm not the kind of relativist that's like, well, yeah, Dubai is like intolerant. Morality is like just as good as ours, or like I want to say like, even though I don't think there's like, I don't think like God is on our side, or I don't think like the objective moral facts built into the universe are on our side. I'm opposed to what Dubai is doing. I think they should, be more tolerant and more accepting. And like, I will like act to like try to convince them of that or whatever.
Oh, interesting. Yeah. Does that in any way conflict with the relativism though?
So I don't think it should or needs to. I think you can, and this is what, I guess this is a part of the philosopher Richard Rorty's thought that I kind of like, because a lot of people criticized him of being a relativist, because he said, he's made a similar point of like, we shouldn't talk about one truth or one correct description. There's many descriptions that are useful for different purposes, etc., which sounds kind of relativist or whatever. But he also he rejected the term relativism, and he said, look, even though I don't think, even though there's not like an objective truth that's backing what I'm saying, nevertheless, I oppose, transphobia. I oppose, beating women. I have these values and I stand by them, and I'm going to act accordingly.
So in the EA community, presumably there are relativists in there, and how do they reconcile that?
I mean, yeah, so there definitely are. I mean, I've met some of them, and I mean, actually, I think so. One self-described EA whose work I like a lot, actually, and who does disagree with me on some of the AI safety stuff, is Joe Carl Smith. Yeah, so Joe Carl Smith has some very good, essays, which are also, he's spoken. He's got like a recording of him speaking them as well, which is nice. Anyway, he's got some very good essays on meta ethics. So like the kind of philosophy of like, what is ethics anyway? Is it objective or not? Or like, what is it about? All of that. So he has like several essays that are good. He's a moral anti-realist. So he doesn't think there's like morality built into the universe. But he does, kind of struggle with some of these questions, because he kind of says at one point, like, well, okay, if we don't believe in objective morality as EAs or just as people trying to do good, are we just kind of imposing our will on the universe? And if you're just imposing your will on the universe, that doesn't feel quite as altruistic as you might hope. It just seems like you're kind of selfishly imposing your own, what you think should be, your preferences, basically. You're imposing preferences. He doesn't, I think he ultimately just says, like, it is like a bit of a, It is a bit like weird or uncomfortable if you think about it, like, from like a kind of a God's eye perspective, like, oh, it just looks like you're imposing your will on things. But like, ultimately, like, if you are acting with other people's interests in mind, like, you shouldn't feel bad about that. That is better from our perspective than just being, a pure selfish person.
Yeah, what do you think about the paternalism in EA? So I agree with you that it is an aggravating factor if there isn't, an actual moral truth to go towards. Because if there was, there would be some kind of moral justification to, almost lead people to a better world. But I think the argument they're making is that they've galaxy brained themselves into coming up with a moral framework and thinking long into the future and knowing what's better in a way that normal people can't understand. Therefore, you should listen to them.
Yeah, I guess so. I don't know if I have like fully fleshed out views on this, but I think there is a potential worry with moral realism that it can be used to justify, as you said, galaxy-brained ideas about what's good. Because you think there's an objective moral truth, if you like go through the arguments and you convince yourself, I guess one way of putting this is like, if you think there's an objective moral truth, you're actually more open to being convinced of galaxy-brained or kind of initially implausible sounding ideas about what's good. Like, oh, we should just like only care about the future and forget about the present or whatever. Whereas if you're not a realist about it, you're just going to be like, well, no, I'm not going to change my mind on this. Like, I'm going to value the present more than the future. And so, yeah, I think, a lot of people talk about the dangers of moral relativism or moral anti-realism, but I think there are at least as, the dangers of moral realism are at least as serious. So you kind of.
What really I mean, I'm just imputing here, but I think what really triggered an interest for you was your fascination with goodness and value and meaning.
Yeah.
You know, almost like that triangle, if you like. And if I understand correctly, in recent years you've been looking into things like Buddhism and doing some bit of a journey there. Tell me about that.
Yeah, so I guess the fascination with Buddhism really it's fairly recent. So in the past, it's definitely like this year. Like I wasn't thinking about it last year, maybe the last few months. And it kind of it was well. So one influence was actually Robert Wright, who I did an interview with a little while ago, and he wrote a book called Why Buddhism is True. And just like being like, being asked to go on his show and then going on his show just made me think about the book, and I eventually read it. I also, I think for somewhat independent reasons, started using Sam Harris's app Waking Up, which kind of guides you through mindfulness meditation. And I did that, I think, like partially just because I was sort of in search for some sort of kind of quasi-spiritual practice, or I just wanted to kind of try it out. I thought like, oh, I'm interested in like philosophy and consciousness and stuff, but I've never meditated. It seems like I should do that, and maybe I'd get something out of it. I also have ADHD, and I thought like maybe forcing myself to be like mindful could like help with that or something. So there are like a lot of factors, but I started meditating, and it's not like, obviously you can meditate without being a Buddhist. Like I'm not even sure if I count as a Buddhist. Like it depends how you define it or whatever. But like it's clearly like connected. Like a lot of the kind of meditative practices come out of like the Buddhist tradition, as well as like Hindu traditions and stuff. And like Sam Harris in the app and in the like kind of there's like a theory section of the app where he just like has these like discussions with people and stuff. He talks to a lot of Buddhists and talks about like Buddhist philosophy, and I kind of got into it through that, and I immediately noticed like, okay, there's a doctrine of like no self, that like there's no, there's different ways of putting it, but like there's it's definitely saying that there's no kind of Cartesian ego or there's no soul that's kind of like continuing on, that kind of defines who you are and stuff. And I've like always, or like almost always thought that, for years. And so the fact that like the Buddha was saying that 2,500 years ago was just like pretty cool. I was like, okay, like he got one thing right, maybe I should. And then just like the analysis of suffering, I think is like fairly compelling to me. Like suffering as like, at least psychological suffering as being kind of being caused by clinging and kind of desire, attachment to the world. There's also this other part of Buddhism that is more metaphysical that I like a lot. It's the doctrine of emptiness, and it's sort of an extension of no self, where the no self is saying you don't have an essence, you don't have a soul, which would be your essence. Emptiness is saying that nothing has a self, nothing has an essence. Okay, and the doctrine is sort of like expanded upon by this philosopher Nagarjuna, who he kind of created this entire new school of philosophy called Madhyamaka, based on his notion of emptiness. And his view is like, okay, everything is empty, and what that means is nothing has inherent existence or essence to it. So everything is relational. So like all kind of objects or like concepts are sort of defined by their relations to other objects. And there's just like a lot of reasons to think this is like a good way of thinking about things. I guess maybe I'll say one more thing and then we can kind of wrap this up. But like in particular, like emptiness would say that the whole debate between idealists and materialists about like what is everything made of? Is it made of matter, or is it made of mind, or is it made of something else? He would just say like, stop asking that question. There's no, it's not made of anything, because fundamentally, this chair I'm sitting on, or my body, or whatever, it's all constituted by its relation, its internal relations, internal structure, and its structure, like the kind of structures that it's embedded in. So I am defined by like my relationships to other people. I'm defined by my relationships to, the fact that I'm sitting on the chair is another relation. That's a spatial relation. And that's it. It's all relations. There's no essence. And so you just kind of get rid of a lot of these like philosophical debates that seem endless.
Yeah, I'm a huge fan of the idea of a relational ontology. I think it was Luciano Floridi who introduced me to it, and the interview we did with him is great. So one of the things, by the way, I love Sam Harris. I supported him so early. I've got a lifetime subscription to his apps, which is really, really cool. And I agree with about 66.6 recurring % of what he said. Okay. But I just love him. His dulcet tones said put me to sleep every single night. But anyway, the other thing was, you were saying something interesting about suffering, because when I do my yoga class and stuff like that, and I'm interested in like mental health and AI in particular. I've read a great book called Lost Connections by Johan Hari, and he's kind of saying that we're now starting to understand depression and anxiety in terms of the psychosocial environment. So it's a very externalist view, and also quite compatible with this relational view that you're talking about. But I think a lot of people that do mindfulness techniques are trying to, and I don't mean this in a disparaging way, but almost trying to address the symptoms. So they're people that they're missing connections in their lives that give them a sense of purpose and meaning and so on. And what Buddhism does, not necessarily all of Buddhism, but one of the practices here is to almost dematerialize yourself so that these psychosocial stresses no longer impact you. What do you think about that?
Yeah, so I definitely think there are ways in which you can like take Buddhism too far, or like take it it can be unhelpful as well. And yeah, like you said, I think if you are interpreting Buddhism to mean that you like shouldn't try to solve any of your problems, or like you should just, I don't think that's the right way to go about things. I would prefer to have kind of a holistic approach where, yes, you like try to solve, kind of improve your lot in life to the extent that you can, but also try to like change the way that you think about things so that you can have more kind of enduring happiness. And like if you do both, like that's probably the best. I also think there's different interpretations of the sort of the doctrine of like, well, there's like 4 noble truths in Buddhism. There's like the source of suffering. The first truth is like the source of suffering is clinging, there is suffering, then the source of suffering is clinging, then there is a path out of suffering, and then the path out of suffering is the Eightfold Path. Those are the four truths. But there's like, that's like very schematic, and there's like different schools of thought about like, well, what does it mean to like kind of end clinging or whatever. I think there are some versions of Buddhism, maybe more in the Theravada tradition, that I find kind of problematic, where they basically say, well, like everything's suffering, first of all. Not that just there is suffering in the world, which there obviously is, but like even like kind of life itself is suffering or something. And then they basically say, well, because kind of everything is suffering, really your goal should be like non-existence, basically. Or like they have a conception of nirvana, this like kind of state of perfect well-being, which is, to me anyway, it seems just like indistinguishable from just like evaporating into nothingness. And for them, I think they can kind of make sense of it, because traditionally they believe in like reincarnation or rebirth. And so for them, it's like, well, when you die, you don't automatically stop existing. And so there needs to be this like eightfold path to non-existence. Of course, like I'm sure, like people are gonna like criticize me and say like, no, nobody thinks that. It seems like at least some people think something worryingly close to that anyway. And so I don't want to be associated with that form of Buddhism. And I think I'm more attracted to the like, I suppose Zen Buddhism probably would be the closest to my kind of like, I don't know, like moral views, because its understanding of like liberation or enlightenment or whatever is much more down to earth. And so, like, for example, it would like they will say that like enlightenment is something that happens like while you're alive. Like it's not like freedom. It's like not at least primarily or exclusively like being like freed from the cycle of rebirth. And they have this view where really what you're trying to do is act spontaneously and in a way where you are kind of not attached to what happens as a result of your action, which might sound kind of like wild or something. It is supposed to be connected to like compassion and stuff. So it's not like you're completely indifferent to the world, but to like the idea is that you should cultivate compassion so that you act in ways that are like beneficial for other people, but also you shouldn't be kind of goal oriented about it or consequentialist about it. It's actually like kind of antithetical to EA, honestly, from a philosophical perspective. It's like it's more, I would say, more kind of virtue ethical, where it's just like cultivating compassion, but you're not clinging to like, oh, I must, like my actions must have these consequences, otherwise I'm going to be like super depressed and frustrated about it. And that's kind of how you kind of relieve suffering as part of this.
Yeah, it's very similar to Kenneth Stanley's book Why Greatness Cannot Be Planned.
Yeah.
And so essentially it's the serendipity part, which is what Kenneth talks about, but also the compassion part, which is interesting. Yeah. But I read a book by Dan Harris many years ago, and he was on the Sam Harris app, and he was saying, oh, this was great. I got this Zen state, but then I had to go to work and I had to get stuff done. And there's this interesting juxtaposition when we talk about serendipity in general, because it's great, but there's also a lot of things in the world that do need goals and objectives and alignment and so on, because we've actually got things to invent, we've got to build societies and so on. So how do you kind of reconcile that?
Yeah, so I think the way, and I don't know, this is all like tentative right now. I mean, I don't, it's very possible that in 6 months I'll be like, oh, actually Zen Buddhism is crap or whatever. But I'm still kind of on a journey here. But yeah, so obviously like we do need goals and kind of structure and stuff. But it also seems like in the future we may need that a lot less, precisely because of AI. So there is kind of this, I'm thinking that there may be this kind of nice, that's kind of Zen and like the fully automated future that we seem to be approaching might be kind of like good companions, because, I'm looking for a philosophy that I think could kind of provide us meaning in life, even when we don't really need to do a whole lot. Like we don't need, at least the humans like don't need to be thinking about like, oh, how do we like run the economy and like have all the, we can just kind of be spontaneous and serendipitous, and the AIs are just handling everything else. So yeah, I guess that the hope is in the future technology could allow us to just be kind of Zen enlightened beings or something.
Nora, this has been absolutely fantastic. I've been a huge fan for a long time now. Where can people find out more about you?
Yeah, so I guess two main places. First of all, if you want to like kind of get involved with like my research and stuff, there's like a lot of people at Eleuther who are volunteers, and so you can go to eleuther.ai, and there's a link on there to go to our Discord, and like there's like multiple channels under the interpretability category there that are like all me, and you can like at Nora Belrose there and get my attention. If you just want me like, I don't know, ranting about things or whatever, you can go to my Twitter profile, Nora Belrose. So yeah.
Well, thank you so much. It's been a pleasure.
Yeah, thank you.